small body, large block of mass capital M. Small mass is pushed with a speed v. Pushed with a speed v. So find the speed of the small mass when it speed of the large block. Small block is sliding on the vertical path. Assume that all the surfaces are frictionless. Find the speed of the large block when small block, that will be a function of small block is sliding on the vertical part. ওই এক্স মোমেন্টামটা কনজার্ভ হবে। আগে একটা প্রবলেম করলাম একই রকম, sliding on the vertical path. So relative to the large block, suppose this goes with v1. Now v2 is the horizontal velocity of both. v1 টা কি আছে? v1 is velocity of small m with respect to capital M, vertically upward. Now this is the x-axis and upward of y-axis. So conserving x momentum, conserve momentum along x-axis. So mv equal to small m plus capital M v2, implies v2 is mv by small m plus capital M. I think this answers part 1. Find the speed of the small block when it breaks off the large mass at height h. Breaks off. v2 to known. When it breaks off, it has x component v2, and suppose this is say v1 itself. Breaks off means এটা এর সারফেস থেকে একদম মানে টপমোস্ট পয়েন্টে আছে, হাইট h. সো এখানে পার্ট বি উই ক্যান অ্যাপ্লাই ওয়ার্ক এনার্জি। ওয়ার্ক এনার্জি এটা হবে mgh is equal to half mv square minus again that half capital M v2 square plus half small m v1 square plus v2 square, because for this particle this is the resultant velocity, root over v1 square plus v2 square. So hence from this you can solve for speed of the small mass and solve and find this root over of v1 square plus v2 square. Else you can do the calculation. Maximum height that the small mass ascends. While it breaks off, it has vertical component v1. So from there, the maximum height is v1 square by 2g. And it travels in a projectile path because it is already having v2. So it travels in a projectile path. And it drops exactly when this, it just touches the vertical surface of the wedge, because by that time its x velocity is v2 and velocity of the wedge is also v2. So they move simultaneously along x-axis. Find maximum height from ground. So maximum height from ground, part C, h plus v1 square by 2g. Can solve it. Show that the smaller mass will again land on the big wedge. Obviously, because both their x velocities are same, v2. So they travel the same path. Find distance traveled by the big block during the time when smaller block was in rest. So that is range actually. Distance traveled by the big block is the range of this projectile. So range is v2 multiplied by 2v1 by g. Time of flight, 2v1 by g time of flight multiplied by the x velocity.